everyone. Today we have our another new episode and we will discuss on autonomous vehicle. We have our world famous speaker, Dr. Tamanna, Mr. Mustafizur Rahman. He is my colleague from North South University, Bangladesh, as well as we have our world famous speaker, CTO of the ETT, Professor David Smith. First, I would like to give chance Professor David Smith because of subject matter expert. He is a CTO, Chief Technology Officers. This is one of the largest business incubations he is running. He's working for NASA and all of the brilliant project. From Professor David Smith, what you want to
Thank you
discuss
so
about autonomous?
Sri, thank you so much for the kind words. I appreciate them. You know, autonomous vehicles are very interesting as you look at it across the board. Many of us, when we use the word autonomous vehicle, we tend to think about towards cars today. So, like, for example, using the Tesla mode where it will drive itself. But the autonomous vehicle is hitting many other different places. You know, we now have airplanes that will fly autonomously, from small drones to very large aircraft, and even combat aircraft will fly autonomously. We're seeing the same thing on the water. We're seeing the same thing going across many different domains. So autonomous vehicles is really one that is guided by many different areas. And almost a way to talk about autonomous vehicles is to talk about autonomous navigation. So if I'm beginning to talk about autonomous vehicles, and I begin to think about a robot in many ways is an autonomous vehicle as well, because it moves, it does things, and it's being done to do them in an autonomous manner. Many of these start out with very large learning modules that can be used to apply against them, but it's really beginning to look at them. And the future of autonomous vehicles is going to change our world. It really will. I mean, I can tell you, I drove a trip, not this weekend, but the weekend before, from Austin, where I live, up to Oklahoma. It was 4 hours each way in the car. And boy, if I had an autonomous vehicle to do that, it would have been so nice because I could have done other things where I could not. But, you know, if I look just at autonomous driving, it is by 2035, it's going to have over $400 billion in revenue. And that's just looking at the passenger car market. That doesn't include autonomous delivery trucks. It doesn't include autonomous railroads. It doesn't include autonomous ships and all that. So it's really beginning to go. Now, it was thought originally that the rollout for this would be much faster than it is, but some of the timelines have been pushed out. And some of the timelines were pushed out because it's a very complex area. One of the tests you do as you're looking at autonomous software is if I'm approaching an intersection and I have an old gentleman on the curb, I have a mom with a stroller with kids crossing the intersection, and then if I go the other way, I'm going to probably go off a cliff and die. What does the autonomous decision made? Is it to go and hit the old man on the curb because he's older? Is it to keep going and kill the mom and the child? Is it to possibly kill yourself? And those are some of the tough decisions that in autonomous vehicles you have to make today that is actually slowed it down some and housed there. And you really have to look at how to develop new business strategies and acquire new technologies in this area, particularly address the concerns around safety, the concerns around ethics, around morality, and what happens when something goes wrong. You know, here in Austin and in San Francisco and Silicon Valley, there's one of the autonomous taxi services that have shut down intersections because they got lost in what they were trying to do, and the cars just stopped, and tremendous traffic jams and things. And it took people coming to override the artificial intelligence to be able to do other things. And you know, these robo taxis, these robo service shuttles, uh, the cross country trucks, the autonomous last mile deliveries are really things that are going to change dramatically. You know, just think if on my trip up to Oklahoma and back, I could have done an hour long teleconference with people. I could have watched a movie. I could have worked on uh, projects for work and be increase my productivity. And you know, it lets me also move further away from the office because I can be productive. So I could move to the rural areas or further on the suburbs. It also, autonomous vehicles could provide mobility for elderly drivers, letting them keep their independence from driving even when their reaction times and things have slowed down. And for example, there was one study that was done, I believe it was by McKinsey, that showed that the adoption of advanced driver assisted systems in Europe can reduce the number of accidents there by over 15% by 2030. So you begin to see a lot of those, and that reduction there is actually at the lower level of it. Uh, there's multiple levels of autonomous driving, and you have level one, which is to assist the driver. You have level two, which is partial driving automation, like you're seeing in some of the trucks today and other things. You have level three, which is conditional, and level four, which is really fully autonomous driving. And those are going to be really fantastic going together. And I will tell you what, if I could go ahead and purchase a full autonomous level four vehicle today and have the safety and everything, I would do it in a heartbeat. And I know many other people that will see. And it's going to be slower to market. You know, by 2030, the penetration is projected between 15 and 20%. By 2035, about 45%. So you see a lot of that coming together. And it's going to be, like I said, a real game changer as you look at the future of transportation. So, Sharif, opening remarks.
Thank you. Now I request Dr. Tamanna.
Yes, I mean, very nice what David spoke right now, and we came to know a lot. But it's an autonomous car is a self-driven class, as per as I understand, and that's what it is all about. Is a vehicle which uses a combination of sensors, cameras, radars, and artificial intelligence to travel between destinations without a human operator. To qualify as fully autonomous, a vehicle must be able to navigate without human intervention to predetermined destinations over roads that have not been adapted to its use. So, companies developing or testing autonomous cars include Audi, BMW, Ford, Google, General Motors, Tesla, etc. So, AI technologies powered self-driven car systems, and developers of self-driven cars use vast amounts of data from image recognition system. So, image determination system is something which is of crucial importance to self-driven cars, along with machine learning and neural networks. The neural networks identify patterns in the data which are fed to the machine learning algorithms. They're like fed into the machine, and that data includes images from cameras, on self-driven cars from which the neural network learns to identify traffic lights, trees, curbs, uh, pedestrians, street signs, and other parts of given environment. For example, Google's self-driven car project called Waymo uses a mix of sensors, lidar, which is like light detection and ranging technology similar to radar, and cameras, and combines all the data those systems generate to identify everything around the vehicle and predict what those objects might do next. That uh, imagination is core to a self-determination car. And the following outlines from Google Waymo vehicles work. The driver sets a destination, the car software calculates a route. So that's the algorithm which it works on. A rotating roof mounted lidar sensor system at a 60-meter range around the car, and etc. But I guess they do face certain challenges as well. So autonomous cars must learn to identify countless objects in the vehicle's way, from branches and litters to animals and people. Other challenges on the roads are tunnels that interfere with the GPS, construction projects that cause lane changes or complex decisions like where to stop to allow emergency vehicles to pass. So, I mean, these are the challenges, and the system need to make instantaneous decisions on where to slow down or to continue acceleration mode. This is a continuing challenges for developers, and there are reports of self-driven cars hesitating and unnecessary where objects are detected in or near the roadways. This problem was evident in fatal accident in March 2018, which involved an autonomous car operated by Uber. The company reported that the vehicle software identified a pedestrian but deemed it a false positive and failed to sever to avoid hitting her. The crash caused Toyota to temporarily cease the testing of self-driven machines on the public road, but its testing will continue elsewhere. So the Toyota Research Institute is constructing a test facility on a 60-acre site in Michigan to further develop automated vehicle uh, technology. So yeah, these are my opening remarks.
Thank you, Mr. Mustafizur Rahman. He's my colleague from North South University. So, what you want to discuss about autonomous vehicle? Do you have any research projects in North South University, your research center?
Okay, thank you. Um, uh, I want to share something about the technological challenges of autonomous driving system. The technological challenges might be the sensor reliability that ensure the sensor like LIDAR and the radar and the cameras used in autonomous vehicles are reliable under various weather and lighting conditions. So that is one kind of challenges. And data processing, handling, and processing the massive data generated by this sensor in real time. That is another challenges I found in some analysis. Software complexity is another thing. Developing a sophisticated algorithm capable of making a safe driving decision in complex, unpredictable real-world scenarios. And some safety and security concern, the accident responsibility, determining the liability in accident involving autonomous vehicles. It's this I discussing this because this need to be addressed when you develop some AI driven car or something like that. Cyber security is another thing. Protecting data and other challenges is there. Ethical and moral dilemmas, decision making in a critical situation, like programming ethical decisions into AI, such as how act in scenarios where accident being unavoidable. And there's some bias in AI algorithm ensuring that AI system are free from biases and could be lead unequal treatment of certain group of people. Another thing is legal and regulatory issues. Regulation and standardization is important, much more important, I should say. Developing a comprehensive and legal framework from the governance and other authority should be addressed. Insurance and liabilities law, the adoption or adopting insurance and liability laws to cater to the unique aspects of autonomous driving. Another thing is the public acceptance and trust that is convincing the public to safety and reliability of autonomous vehicle. And another part is related to this, that transforming traditional driving, the managing the transition period when autonomous and human driven vehicles will share in the road. Another challenge is I found the infrastructure adoption, monitoring the existing road infrastructure is better accumulated support to autonomous vehicle. And this should be need to address the traffic management. These challenges requires a collaborative effort from technologists, policymakers, legal experts, and society as a whole. The path to fully autonomous vehicle is not just adjusted to a journey of technological advancement, but also one addressing complex societal and ethical questions that I should say. Thank you.
Thank you. I request all of you to open your camera because our audience actually observing the show. So when the audience point of view, you go and stop the camera. I think this is difficult for them to understand our dialogue. And I have more question. I think Professor David Smith, you can give some sort of guideline what actually my colleagues bring, some of the challenges. Maybe if he can understand what type of benefit we have from autonomous vehicles, maybe he can identify the solutions for our things. And I have to ask you the question, what are the key challenges and ethical consideration what actually my colleague bring in the development and deployments of autonomous vehicles and how we can resolve it?
Well, Sharif, that is a great question, and one that has many different components to it. Now, if I begin to look at that, I have to talk about both technology and non-technology things there. So, for example, autonomous vehicles are machines that don't get tired, and that I know my driving gets worse when I'm tired or if I'm having trouble staying awake and stuff. So, autonomous vehicles, that goes away. Uh, Systems do not have emotion. We've heard the term road rage and everything there, and it's really true. But an autonomous vehicle doesn't have emotions. There's not a risk of drunk driving in an autonomous vehicle. Even though they make mistakes because of their programming, robots and autonomous vehicles will tend to make fewer mistakes over time. Self-driving cars are programmed to follow the traffic rules and the traffic laws. So if you do that, theoretically, our time in traffic should decrease because they're all following the same laws. And again, you heard me mention earlier, one of the other pros is improvement in mobility for people who can't drive. It could lead to lower insurance costs. I hope so, because insurance has been rising disproportionately high lately. I can work while I'm driving. It will potentially improve air quality because of the way it's done. And there are economic advantages to it. What are some of the cons, though? You know, you're going to see with autonomous vehicles higher unemployment rates for people who were cab drivers, who were long haul truckers driving across the highways, even last mile deliveries when they become autonomous. It's one of the things that I can relate to. People may unlearn how to drive manually. You know, I grew up using standard shifting, and now you almost cannot buy a car with a standard in it. It's all automatic transmission. Well, if I'm driving fully autonomous vehicles, particularly level 4, level 5, I might forget how to drive manually. Autonomous vehicles have a higher R&D cost and maybe higher initial purchase price because the cost of the autonomous software, the cost of all the extra sensors are on top of the typical vehicle cost. Maintenance might be very difficult and costly. Uh, and how about privacy? If I'm being driven autonomously, uh, the car, the system, probably even the cloud will know everywhere I went. So my privacy might go down. You heard me talk earlier about some of the moral and ethical concerns. You know, if you're presented with a situation like that one, what decision does the car make? Uh, what happens with technical errors? Like with the taxis here, do you just stop even in the middle of an intersection until you figure it out? Hacking. Well, I can see as every industry is open to cyber crime, cyber security, hacking, autonomous vehicles are going to be ripe for that initially. Also, one of the other challenges, Sri, is that bad weather might prevent some of the sensors from working properly. So that is a challenge that they're working to try to overcome today, but there's still a lot of work being done there. So bad weather is one of them. Uh, I know many friends who say, I cannot wait for autonomous vehicle. And I also have groups of friends who say, there's no way I would ever drive an autonomous vehicle. I don't trust technology that much. Uh, you're going to probably see increase regulatory restrictions as we see more and more autonomous vehicles on the road. And also, you're going to find out that, and this is a strange one, there's going to be insurance challenges. So if I'm driving my car and I have an accident, my insurance knows I did it. If an autonomous vehicle is driving, is the autonomous vehicle at fault as opposed to me? So does the car need its own separate insurance driving autonomously than me when I'm driving manually? And by the same token, one of the promises with autonomous vehicles is that you might not have to own a car, but you can pool autonomous vehicles and have them come pick you up, take you where you want to go when you're needed, which would reduce the amount of vehicles on the road uh, and things. But, you know, as we do that, how does that work? Who's responsible for an accident? Who's responsible if someone dies? And all of those things. So there's this whole issue of both the pros and the cons, which those are just a good subset of them, Sharif. But I hope that answered your question.
Yeah, thank you. Dr. Tamanna, like what you want to discuss about the impact of these autonomous vehicles?
Yeah, impact as far as technology is concerned is good, but obviously, as we have been discussing about the challenges, they are not less. So we have to be very careful, and many countries have upheld many legislations, and so has India also. So, for example, in UK is one of the most developed countries in the world, and it's almost fast forward country to regulate autonomous vehicles. In 2018, they passed an act, the Automated and Electric Vehicle Act 2018. Section 2 of the act explicitly mentions that the owner of the vehicle will be held liable for any accident involved. The same principle applies in case of death due to accident. Further, Section 4 of this Act specifically mentions that if the autonomous vehicle is insured and the accident is caused, the liability of the owner decreases. But in short, the Act does not mention the liability of the manufacturer of the car and who has developed the AI system, but it clearly mentions the liability is of the owner of the car, even if it's a fault of AI. So, this is another thing. But in early 2022, the proposed plan of UK of 2025 for self-driven cars mentions that manufacturers and not the owner will be held liable. So, yeah, in US, for example, it released a federal automated vehicle policy in September 2016, which would also update annually. Section 2 of the guidance spoke about this particular aspect, and 11 states and districts of Columbia have passed legislation related to autonomous vehicles, but all these vary in their scopes. Now, in India, being a country, we for the first time we launched a which is called 1 second, yeah, Z-Pod. By some engineers, they brought about this particular act, and yeah, so in India, two legislations have been passed hitherto, and I mean, the act which says that anybody who uses this technology is responsible for it as well. So India has a long way to go, understanding what the autonomous vehicles challenges, because Indian roads are still developing in infrastructure, and if you look at the small towns for example in Patna, for example, or you look Bihar, the state of Bihar, there's a total chaos. UP, there's a total chaos. So it's still better now. So how automated vehicles are going to operate there, that has to be seen, and a better technology has to come by our engineers, so that not just the road accidents have to be saved from, but also that the roads have to be constructed in a way that automated vehicles are able to move around in a better way. And yeah, so I guess uh, I mean, it is like India is buying many of these resources from for example Israel, the chips and system for advanced driver assistance. These are the technologies which are being purchased by Indian government, and so I guess that is. But for Jerusalem-based auto equipment measures, Israel's most valuable publicly traded company by market capitalization, an unexpected surge in demand from India for its next generation systems on chip and sensing and mapping software for driver assistance technology over the last 12 months, or has resulted in order inflows from India surging to nearly 4 times what company has originally forecasted. So India is collaborating with different countries for a better system. I guess rather than concentrating on automated vehicles or self-driven vehicles, we need to focus on our architects on how and engineers how to build better road systems, so that the accidents which have increased over the years should be reduced with the help of these vehicles. Thank you.
Thank you. Mr. Mustafizur Rahman, what you want to discuss as the impact of autonomous vehicle? What do you think about Bangladesh?
Okay, thank you. As Dr. David and Tamanna said perfectly, as they said, the infrastructure development and infrastructure challenges, this is a core issue for Bangladesh. I think the infrastructure challenge is one of the
core issue. Bangladesh road infrastructure might not be fully
It went
prepared
it
for
went really
autonomous
well. I
vehicles.
sent you a copy of an email I received from Ryan.
Traffic contribution and proper signage in the direction of autonomous and solution could be solution government in the infrastructure and is crucial, including roads, improving traffic signal system, ensuring clear road and marking and signage. Another thing is technological adoption and investment. The challenges, the high cost of advancement of AI, investment and partnership of companies can help actually. And additionally, investing in education and training programs to develop local expertise in artificial intelligence and automotive technology is vital. The regulatory and policy framework of Bangladesh, the absence of legal framework for autonomous vehicle can impede their introduction and safe operation. The solution could be the government need to specify the develop and implement a specific regulation standard for autonomous vehicle. This includes law related to safety, liability and insurance, as Dr. Tamanna mentioned. Traffic management and safety system. Bangladesh traffic condition and characterized by a high density and diverse modes of transportation pose a unique challenges for AI vehicles. And solution could be implementing AI in public transport system first. And then buses or shuttles can adopt the technology of for two local conditions. A pilot project in control environment can provide valuable insights. The another thing is public acceptance and awareness challenges. There might be skepticism and resistance from public regarding the safety and reliability of autonomous vehicles. The solution could be conducting awareness campaigns and education program. Access to education can much more creating much more awareness in the public level, and about the discussing about the benefits and safety features of AI can help you out building the trust. Another challenge is the impact is economic and employment concern. The challenges is the shift towards AI vehicle might impact employment in the traditional transport sector. So the solution could be developing transition plans, workers in affected industries, including retraining from and education program can mitigate this impact. The cybersecurity, as David mentioned, and data privacy, protecting and data privacy system of autonomous vehicle is hacking and basis of concern. So the solution could be establishing a strong cybersecurity and protocols with international cybersecurity, with the collaboration of international community that could be enhance the security system of this system. I mean the cybersecurity system. So by addressing these challenges with a protective solution and strategic planning, Bangladesh can pave way successful integration of artificial intelligence and AI vehicles in potentially transforming its landscape, ensuring safety and efficiency. Thank you.
Thank you, Professor David Smith. There are few technical questions I want to ask you because of subject matter expert. What measures are being taken to ensure the cybersecurity of autonomous vehicles? and like how do autonomous vehicle communicate with each other and with the surrounding infrastructure?
Well, Sharif, you've asked a couple of different questions there, and one of them are more sophisticated than others as you look at the different levels of cars that you have. So autonomous cars rely on a wide variety of sensors, actuators, a lot of really complex algorithms in their data science portion of it, machine learning systems, vision recognition systems of all different types. So what happens is autonomous cars create and maintain maps of their surroundings based on the sensors and the different parts of it. Plus, they interface into existing geographic information systems, local updates and things too. The radar sensors, for example, monitor the positions of nearby vehicles. Video cameras detect things like traffic lights. They read road signs. They track other vehicles, and they look for pedestrians. LiDAR, which stands for light detection and ranging, which is using basically lasers. Sensors bounce pulses of light off the car's surroundings, and they measure distance. They detect road edges. They identify lane markings, and ultrasonic sensors in the wheels and on the side of the vehicles detect curbs and other vehicles, for example, when parking. And then the software, fairly sophisticated software, processes all the sensory input. It plots a path and sends instructions to the car actuators, which control things like acceleration, braking, steering. And there are hard-coded rules in there, such as avoiding obstacles, predictive modeling, object recognition, which really help the car follow the traffic rules and navigate it. And these, like I said, are all tied into the local GIS system so that they can also know the rules of the roads they're on. They can also tie into things like the weather conditions so that they can change some of the parts that are doing there and begin to do some of the areas like that. And like I said, Sharif, to answer your earlier question on that, part of what autonomous vehicles have to do is also understand the emotion. They have to understand the tendencies of how humans react. If a simple algorithm to say a person crossing the street might continue to move in a straight line at the same velocity. But the reality is we've all seen it, when people see a car coming, they might stop and freeze. You've heard the phrase, a deer in the headlights type look. That has to be built into the software. What if they turn around and run back the other way? If they run the other way, all those are variations to a common modeling approach that we would use traditionally. And all those have to be incorporated into the systems that control the autonomous vehicle. So I hope that answered your question.
Yes, Professor. Professor David Smith, what's the closing remarks for today's session?
My closing remarks, and thank you, because I do need to get on this other call, are really autonomous vehicles are coming. I cannot wait to see autonomous vehicles move up the scale, from no automation to driver assist to partial automation to conditionally automated to very highly and full automation. I cannot wait for this to happen and go forward. It will be a slower process than most of us want to see, but it's one that we're there. And like so many things, we have to do a lot of education to get people and systems adapted to autonomous driving. We need to look at how laws have to change, how business have to change. And we're going to do that as we move forward. But I for one am excited to see this. The earliest implementation of fully autonomous will be in the long haul trucking industry. It will be in airplanes and others. And we'll eventually see it go into the new ones. But Sharif, thank you so much for letting me be part of this today.
Thank you for excellent contributions. Dr. Tamanna, what's your closing remarks for today's session?
Yeah. I guess that India, I mean, developing world is now moving towards more of these automated vehicles, and India, Bangladesh can lead the way, exchanging their technologies with each other, and more than that, the road infrastructure, as Dr. Rahman was also saying, that we need to have, in Bangladesh, for example. So I guess the SAARC countries should come together, and we should have techniques how to make roads more safe, because there are a lot of cases of hit and run cases here. So I guess the automated cars and should be able to have systems whereby these accidents should be reduced, and secondly, what I would like to say is that women should be given more control, because women, I'm sure these cars are going to be more expensive and difficult for women to buy themselves. So I guess the government should subsidize these, and loans should be given to women to buy these, because this would be easier for them to drive, and many of the women who are not driving right now would be able to drive, and with lesser amount of money being invested in them.
Thank you. Mr. Mustafizur Rahman, what's your closing remarks for today?
Thank you, Dr. Sharif, for a nice seminar. I want to express my heartfelt gratitude to each of you, esteemed speaker, dedicated participants, and our organizer. So, contributed a rich discussion. Today, we have journeyed through the involving landscape of autonomous vehicles, gaping the complex technological, ethical, and regulatory challenges, and embracing a future transformed by this groundbreaking innovation. As we part always, let us carry forward the spirit of collaboration and curiosity, remarking the road of mastering autonomous vehicle technology is much about the journey as it is in destination. So let's continue a path of research, policymaking, and ethical consideration, ensuring the towards of autonomous vehicle. We do so with commitment to safety, efficiency, and the betterment of society. So thank you all, and I would like to conclude in this seminar. Thank you.
Thank you. Thank you for your excellent contribution. I request all of our audience, please share our content as much as possible, like it's like open source mode. And everyone, please share our content as much as possible, because definitely we have a lot of content. It's for development. Even Mustafizur Rahman, you are part of North-South University. Any student, any faculty, any department, they can use our content. They can develop it as a case study methods, and they can contribute for us, and student can learn many different aspects, and by this way we can enrich our community. Dr. Tamanna, I know you are also part of academia. Your academy also can share our content. They can distribute our content. It's 100%
Sure.
free. So
Sure.
that is the things we work as an open source mode. Everybody can use. It's 100% free. Nobody has to pay for anything. And thank you everyone for your excellent contribution. Thank you. Bye-bye and take care.